Hello everyone, and now I am going to demonstrate the CAD modeling to model the assembly of a flange coupling using a Creo solid modeling package. And here you can see the component drawing of all the parts in a flange coupling. You know, the flange coupling is used to connect two shafts and which are completely balanced, and this couples two shafts so that the power is being transmitted from the driver to the other shaft, and uh, this is achieved by using the flange and nut and bolt arrangement in this way. And as you start the diagram, we will analyze each and every part that is used. The main part is the flange. The flange is the main part, and we have got two flanges and two on the either side, and a shaft, two shafts on the either side, key to fix the shaft, key to fix the shaft in the flange, and then bolt and nut arranged around the flange to hold the flanges together. So we see the dimensions that is required. We need a first of all, when you start drawing, we need to draw this circle. This circle has to be projected to get this disc. After that, you have to draw another circle over here, and that has to be extruded to get another disc. And we are trying to create the first part. We are naming the part as flange, and we are selecting part solid, selecting the datum, and start sketching in that XY axis, drawing the outer circle, and then you know the dimension is 190 for the outer circle. That is a disc of the flange. Now we extrude to the required thickness that is given in the question. So we got the extrusion now. This is the extrusion. Now in this plane we are going to create another one extruded circle, cylinder like projection, inside which the shaft is going to be fitted. So now sketching a circle in a plane of the disc, and we dimension it as 90 because that is a dimension. Now extrude it. We dimension that extruded height as 55. Drawing a circle in this part to create an extrude cut, the hole or the space to insert the, here is where we are inserting this shaft into it. So this shaft should go into this system, so this hole should be throughout. So now we go into this and we create key OK, and we create the extrude and extrude cut, through extrude cut, and extend it towards the end. So the hole is going all together till the end. Now we have to draw the keyway in this system. Before that, we will draw the holes to, this is the hole. So this bolt and nut arrangement will be assembled in all these four holes. Okay, that's why they're given 4 holes of diameter 12. There is some clearance allowed, that is what. So in industrial norms, always they give a tolerance for each and everything, because n number of part when they are manufacturing, there may be slight deviation. That is a tolerance that is provided in the drawing. So this circle we create, and then we extrude it, cut it, and we can replicate this extrude by using pattern. Go to pattern, and then axis as a reference, we create the pattern. So pattern is created. Now we have to sketch this keyway. So we take this portion. Here we are drawing the keyway, and the dimensions, keyway dimension is given, sectional dimension is given. So in the shaft also we have to give a space where keyway is inserted. So now we go for the centered rectangle and draw the rectangle, and you parametrically change the dimension and trim the unnecessary lines extending inside this space other than the surface over here. So we cut we trim these regions. So we get this portion, and now we extrude it. So we get the exact extrude in the flange, extrude cut. So we can save the first part that we have created. It's a flange. You can choose suitable name and save it in a separate folder, so that during the assembly it will be easy for us to take it and assemble. So we create the name as in the bill of material, part 1. So part 1 is created. The part 2 is the shaft. The shaft is over here. So we have to create a shaft and also a place to insert the keyway. So we name the part now. So part solid, create the data, go for sketching, and the shaft is a circle, extruded circle. So create a circle and then extrude it. We get the shaft now. So take the dimensions of the shaft, length of the shaft from the drawing, and now you can start drawing the keyway. As we did in the flange, here also we can create the rectangle with center reference and then cut away the extended portions using the trim option. Here you are drawing the circle, so that line is created over here. This line and all this rectangular line will form a boundary to form an area, so we can trim all the other portions. So you can extrude cut through to a distance that is required, because keyway will not extend through the shaft. It's required only for the fitment. So the distance as given at 90, so up to that you can give the slot. So chamfer this corner. So create the part 2. We have created the part 2. So we are going into the diagram and see what else part we have to be developed. So part 2 is over. So now we have to create taper key, bolt and nut. So key, taper key. Creating sketch of that rectangle. So because the section of the taper key is rectangle, so create a rectangle and the length and breadth is decided. Now you can see the part 2 is ready. You can see it carefully. 14, and then here 9. So you extrude and then you give 90. So you get the proper keyway slope. Since the slope that is required is 1:100, so that is achieved in this part model. Now next is the bolt and nut. So we need if you go here sketch palettes, you have got a 6-sided hexagon. From the sketch palette we can take the 6-sided hexagon directly and then extrude it. You know the dimension, put in the required dimensions and extrude. So now you sketch the circle in a surface of the bolt, so that you get the cylindrical portion that is found in the bolt. So this length is 18 plus 34. So 18 plus 34, we extrude the circle with a length equivalent to 18 plus 34. So which is 52. So we extruded, we got this. Now we have to shape these corners. So for that we sketch in the top portion of the bolt a circle, and then you take tangent, you extend the circle to this. Okay. So extrude, and then the extrude option, you extrude cut, and then options you go for add taper, and then options you go for add taper. So then after going to add taper blind, after giving add taper, you can adjust this to get the desired shape. See here, you can adjust this. So keeping it 40, then we get the desired shape. So first the circle is made into tangent, then you extrude cut. We are using the option to get. So next is the nut. Very similar to this. So we take from the palettes. So we go to palettes, and palettes we got 6-sided hexagon again. We fix it here and parametrically change the dimension. So now extrude it. You have to extrude the inside circle, extrude cut throughout. Now we have to do the same trimming operation that we done in the bolt. So draw a circle, make it tangent, go to make it tangent to this all sides, then again go to extrude cut. In the options you go to add taper. In the options you go to add taper. Now we can change this. So previously we kept 40 and 45 we kept here. So now we get the desired shape. You can repeat this plane. You can see here how the same can be transformed to the other side. The same procedure can be transformed to the other, mirrored. That is plane. We check this plane and then go to extrude part and then mirror it. So mirror with the center plane. When to center plane as a reference, we mirror this. automatically this will be mirrored this side. So keep the center plane as a reference so that the mirror of this trimming that you have done on one side will be trimmed on the other side also. Now we get the, so in assembly we are taking the part one by one and trying to fit into a constrained assembly solid model. So we go into assembly design now. Template, we are choosing the assembly design template and go for the assembly, and then go to the folder that you have created the models, part models. Choose the first part. This will be shown here. Take it out and you go to the default. So assembly component at the default. So accept here. Now again you go to assembly and take this part again, because you need the two flange on opposite side. So you can rotate it and match it to this axis. Now we have to constrain it so that this fit in. We manually rotate. See that. Now to constrain it, we choose coincidence automatic from here to here. One point, one hole to another hole coincidence. So here also surface extrude we are using coincidence, oriented coincidence, and also this disk coincidence also we can use to assemble. So we use this disk and this disk, this surface coincidence. Yeah, now the flanges are in contact in proper assembly way. So we take away the other part, shaft. Similarly we give constraints, coincidence. So it says partially constrained because the rotation is, it is allowing the rotation. So we have to give a surface coincidence for at the keyway, so that the rotation is prevented. So it is also going inside. So we should define some distance in which it should stop. So this distance we define so that the shaft will not will put it outside for some distance. So we have defined it. Now again we take the shaft for the other side, and here also we have to give two constraints. One is to coincide this surface with this, and avoid the movement of the shaft. We give the constraint, distance constraint, in which it has to stay. So we give the coincidence. We use coincidence here, and also from here to here the distance. We give surface coincidence, then the coincidence of the keyway, and also the and also we are providing the distance to avoid the linear movement. So now we can take the other parts. Bolt, we give the nature of contact between the bolt and this flange, and it is inserted properly by coinciding the cylindrical surface with the hole surface. The reference axis, you should choose the reference as axis. You can make a pattern so that this same thing is repeated. Reference as axis, pattern. So this will be repeated for all the 4 holes. We take the nut, we constrain the nut by giving the surface coincidence. Coincidence, so it coincides, you can see here. So again pattern, choose this, give pattern, axis as reference, it will fix the other nuts. Yeah, so it has, you got the assembly. Then we have to fit only the keyway. Choose the keyway. For our convenience, we choose the keyway at last. So now you rotate the keyway from the to the way in which it has to be fixed. So it has to be inserted this way. So which surface has to be in contact, you have to find out. We choose this bottom surface and this bottom surface, this bottom of this key and then bottom, so that it fix it properly. It doesn't allow the additional movement while it is transferring the transmission from the driver to driven. So we are taking another keyway and again fixing the surface contact, finding the exact face in which it is touching the bottom portion of the shaft. Yeah, so that now again we are using coincidence to fix it. So this is the surface, it is going to be in touch with this surface. Now we choose both the surfaces, and when we give coincidence, it fixes it properly. Now we pull it up for its better fitment. So now we have all set for visualization. For giving a better visualization for the vendor or your co-workers or your team members, you should give it will be easy for differentiating the parts and for easy understanding, and then product development. This kind of rendering and coloring will be helpful. So sometimes, not every time good experts are seeing the diagram. Sometimes a layman also should be able to easily understand your drawing. So this rendering and perspective views will give a clear imagination of how this product will look in a real time. So you can play with this whenever you are getting, after drawing the diagram, if you get time, you can play with this coloring, rendering. So this is what we have obtained. But even then, after completing the diagram also, sometimes you may see some errors. So in that case, you can directly go to the part and we can correct that also. We can see the shadow of this image now here. Shadow. So the shadow, reflections, lighting, everything can be perspectively seen. So now there is a small, mistake, modification we can do. That is a roundness in the edges. Actually there we can include a small roundness in the edges actually. So we choose that, can say roundness or fillet. Okay, So we create this, the roundness in these edges. We have created the roundness, and you can see here that will appear here in the assembly. So we have created, and that's all for today, and thank you for listening, and hope you can do a better assembly drawing with flange coupling. And anything, we let you know in the comments of LMS. Ready to help you at any time. Thank you, students.